Systems and Computing Technologies Division and holds the rank of tenured associate professor in the College of Business, Engineering and Technology at Texas A&M University in Texarkana, Texas, USA. Sir has over 2 decades of experience in teaching several courses in computer science and management, information systems. During this time, he has developed several new courses and programs that focuses on new technologies. Dr. Bhadoria is a prolific researcher who has several publications in reputable journals such as Journal of Association for the Information System, Journals of Database Management, Computers and Human Behavior, and many more. Sir has over 25 conference proceedings and over a dozen presentations in several national and international academic conferences, seminars, and workshops. Dr. Bhadoria's research has high citation, which speaks highly of his contributions to the body of knowledge. His current research areas include software development methodologies, environmental sustainability, security, blockchain, IoT, and self-driving technology adoption. We are fortunate to have such an eminent and scholarly personality in today's panel of discussion. Today's online topic with Sir is the future of technology. Will we be ready?
Yes, sir. Now you can start, sir. You can share the screen and you can start, sir.
Hello everyone. Are you able to hear me?
Yes, sir. We hear you.
Okay. Okay. So I had sent the slides to
Okay, sir.
Vikbalji before, and if you want to use, you can use that at the auditorium.
Yes, sir.
I
Sure.
don't really need the slides, so I can really start talking. But if the slides need to be shared, then I had sent them.
So you share the screen, sir, or I will start the slides?
Okay, let me share the screen then.
Sure, sir. Yes, sir. Screen is visible, sir.
Just a minute, I'm
Yes, sir.
trying to. Okay. So, are you seeing the screen now?
No, sir. Not right now.
Okay. Let me try. Just taking. Okay. I think the screen should be available.
Yes, sir. It is visible, sir.
Okay. All right. So, are you able to see the entire screen?
Yes, sir. Yes, sir. We see the entire screen.
Okay. Very good. So, hello everyone. My name is Vikram Badoria, and I'll be presenting on this topic, the future of technology. Will be ready? And first of all, let me thank Dr. Neeraj Srivastava, Madam Archana Kirti Chaudhary for organizing this event. And this is really a very important and very good opportunity for all of us to be able to share and exchange ideas and kind of reflect upon where we are and where we are going. So I will want to start my talk with what exactly is technology and how over the years it has evolved. So as you can imagine, technology, the very first time when a man started fire or used stone as a tool for hunting or for finding a knife out of the edge of a stone, that was a technology at that time, right? So the whole purpose of any technology was to act as an enabler, and it enables to enhance productivity. So you are able to get more output with the same or less input, and therefore it reduces your effort. So the whole purpose of technology was essentially from the very beginning was to enhance the efficiency. So get more done with less effort. Now, one important thing, and why it is important to mention here before we move forward, is that efficiency is only meaningful in the context of effectiveness, right? And I'm sure you must have heard this before, that effectiveness is doing the right things and efficiency is doing things right, right? Peter Drucker said that long time back. So the efficiency can only be judged in the context of effectiveness. That means you should be doing the right thing in the first place. Otherwise, doing it right or wrong is pretty much uh, meaningless, right? Now, over the years, as technology evolved, it also became a source of power. And initially, as you can imagine, when the machines were not as much evolved, when the tools and implements were more agricultural and more from the hunters and gatherers perspective, the most of the energy efficiency came from people who had muscle power, right? People who could do physical labor more. So at the beginning, whoever had the muscle power or whoever rather had the technology was used to basically have this brute force muscle power, and that became the source of power, enabled again by technology. Then, as the civilization evolved, as the species evolved, we started coming up with mechanisms in which we could accumulate our labor. And that is why the barter system and then the currency came into being. And then money became the source of power because money could be exchanged for labor, money could be exchanged for any kind of equipment. And therefore, whoever had the money, they could invest in the capital, right? It was for the capital expenditure. And that is how the industrial revolution in Europe started. And till recently, money was the major source of power. The richest nation was also the most powerful nation. But now, as we move towards um, motions using knowledge as the basis, is basically having the mind power. So, how does our mind get its power, or how does the mind, when is applied in the context of technology, how is technology enabling the mind power? And in this enablement, something very unique happens, as I will discuss in my next slide. But before that, let us quickly uh, think about, when you talk about mind, you're talking about processing data essentially, right? So you have got data which is basically raw facts, and you are trying to put that in the context, right? Because context has the meaning, and it is the context that makes the data information. For example, I tell you a number, 78. Now, it doesn't mean anything unless and until you know what it is. 78 kgs. It is the weight of a person. 78%. If somebody passed the exam, 78,000 rupees. That could be maybe a salary or something, right? So it is the context that you put around the raw data which makes it information. And then when you perform analytics on this, when you start analyzing it further, at that time it reaches to a point where you can take action, you can make a decision. So suppose you have got 78, and suppose that happens to be the stock price of something, and yesterday the share price was, let's say, 75, today it is 78. You can make a decision whether you want to sell it or buy it, or not do anything. So that decision is based upon processing the information even further. So see how the data processing is going forward. And when you have taken a decision, you get a feedback in the sense whether it worked or not. If it worked, you learn something. If it did not work, you learn something from that scenario as well. And that is what leads to probably your learning or your wisdom. This is technically called double loop learning and all that. I'm trying to keep the jargon out and getting to the facts, getting to the bare bones facts first. So technology is definitely a source of power, and mind is always trying to get more and more quote unquote intelligence, wisdom, knowledge out of all the processing of data. Now, mind today is no longer just human. Bear with me. When we say mind, we are always talking of human mind, correct? But whatever the human mind can do, and I'm using mind as a metaphor for processing, right? So you can replace that with brain. Whatever a human brain can do, the same things can be mimicked by machines now. And when the machines mimic that, the intelligent machines, something very fundamentally different happens. And what is that? First of all, just like we have got our five senses, machines can also have their sensor data, right? And this sensor data is representing the materiality out of this or the reality around them in digital form. So the reality is expressed as zeros and ones, essentially, if you want to call that. And it is driven by an algorithm which builds a model around that. So if you're talking about, for example, a sphere, for us, when we look at the sphere, we do not really think about the radius or how the surface area it may have, or what is the curvature and all that. We don't think about that. We just look at the sphere. But when the intelligent machine is getting that information from the sensors, it is actually running an algorithm to kind of see what we cannot see. And therefore, our knowing is biased by our perspective. A machine's learning and knowing, being synthetic, being the human, what you call limitations are not there. And therefore, a machine is able to see a lot more than what humans can see. And this knowledge, which the machine is extracting from sensors, is generative, right? You have already, I'm sure all of you have at one point in time or the other have already used ChatGPT, and you know what generative large scale models are creating this kind of talking machines now. The knowledge is expandable, you can expand it, it is ubiquitous. So it is suddenly available to all the models. Kind of negative things, if you will. The knowledge that intelligent machines and algorithms just a few clicks. And this knowledge can be used for political advantage. It can be used in a very biased way because your uh, insights from data move further. But if you want to come back and revisit how it is political and how that biases are there, that is an interesting question. And machines and algorithms, as you can see, is actually surpassing the human intelligence and the human processing ability already. What is the processing ability of a human mind? Maybe 100 bits per second, maybe, if that. But compare that to the computers now. It is millions and millions times of that. So as far as the processing is concerned, machines are already surpassing the human intelligence. Now, what are the enablers of this revolution in artificial intelligence, if you um, want to know? There are three important enablers that are making this happen. One, the computing power is becoming much and much cheaper. And an example of that is in Human Genome Project, the amount of computing power that was needed, the amount of money that was spent to get that computing power. Today, you can get the same computing power for 99.997% less. And let that sink in, for 99.997% less. So pretty much you are able to get the same kind of sequencing capability, the same kind of computing power that was used for genome sequencing just 25 years back for 0.003% of that cost. So the computing power is becoming tremendously cheaper. And now we have got better understanding of human biology as well. So much so that targeted gene therapy is the cutting edge research in cancer therapy. And we are going all the way to the molecular level. And we are able to really target the specific cancer cells and, kind of, act on that. The third enabler is miniaturization of devices, because now the devices are can be produced, and they can always, or they can be reduced to the point where they can be created almost at the molecular level. So nanotechnology and this nanobots, and when we say nano, it is 10 to the power minus 9, right? So 1 billionth of a site. So naturally you cannot even see it. But at the molecular level, the nanobots can be inserted inside the human brain or in the human body, and they can perform tasks. So these three enablers, computing power first of all becoming cheaper, now we understand the human biology better, and this miniaturization of devices and nanobots, that is going to revolutionize the coming years. And we are very fast approaching what you call technological singularity. I'm sure you must have seen that movie, The Imitation Game. That was a great movie, and The Imitation Game is originally was started by Alan Turing, who is also called the father of artificial intelligence, father of computing. Um, and when he came up with this idea of measuring, so the imitation, the focus, the main idea of the imitation game of the movie showed differently and all that. But the main idea behind imitation game was this. And now that eventually was called the Turing test. The Turing test essentially provides input to somebody from a human actor and from a computer. And the a person is to judge and to quickly tell which of the input is from the machine and which of the input is from the human being. So when it started in 50, I think right around 1956 or so, the time it took for somebody to identify whether the input is coming from a machine or a man, it was just a few minutes, 2 minutes, 3 minutes. And when they reached 5 minutes, they said, wow, we have made such a big progress. Now that it is, for 5 minutes, you cannot tell whether you are talking to a human being or to a machine. No machines have yet fully passed the Turing test. Google had one of their products kind of come very close in 2018, and there are some other claims from some other companies as well. But no product has yet passed that Turing test. What simply means is that when you're talking to a machine, eventually the human being will be able to tell that they are talking to a machine, right? Even if it takes several minutes, even if it takes like 45 minutes, 1 hour. But there is always a point when you can tell that you're talking to a machine, correct? Now that is all going to change. Machines will completely ace the Turing test. And by that, I mean that you can talk to a machine all the time you want, and you will never be able to tell whether you're talking to a machine or you're talking to a human. So the machines will be able to mimic the human intelligence and the human interactivity to the point that the human they are talking to will not be able to tell them whether uh, they are apart from their whether they are human or whether they are machine. And that will be 2029. 2030s is when you will start seeing what you call the some sort of anecdotal evidence of technological singularity. But by 2045, it is projected, and some say it is by 2040. So in the next 15 to 20 years, we are going to a point where all the human intelligence will be completely surpassed by AI. And AI will be surpassing human intelligence. They will be acing the Turing test. They will be, for us, it will be at that point in time almost impossible to control what AI does beyond that. And at that time, the AI will actually start self-replication. It will start creating their own AIs, which is already, you already start seeing that. In fact, it happened in Facebook. I remember you might have read that in the news that uh, uh, they were experimenting with two AIs, and the two AIs started communicating with each other. It was a negotiation about a car or something. So they were mimicking that car dealership type of environment. And they found that the two AIs had started talking to each other in a language that humans could not understand. So they had to shut down it because they did not know where it is going. And so that is a peril. Learning of AI, as you can imagine, is exponential. I mean, they learn very, very fast. So whatever a human being learns in their whole life, an AI enabled kind of machine can learn that maybe in just a few days. So once the technological singularity is reached, many things will happen. One of the things that will happen is that the global north will become even more north, and the global south will become even more south. What I mean by that uh, is this: that the disparity between developed nations and developing nations will grow even more. And why is that? Because the global north already has got infrastructure. So they have got high speed internet connectivity. They have got um, uh, proper energy sources, so there is no energy crisis. Electricity is there 24 by 7. Um, and they have got the cutting edge research, because most of the research in AI that is happening in the north, the global north, I mean the developed countries. Therefore, the when the AI will be implemented in, for example, manufacturing, or in for example, healthcare, in cancer diagnosis and whatnot, the global north will be able to make advances at a much faster pace than the global south, because global south does not even have 24 by 7 electricity, for example. They do not have as much high speed internet connectivity. They are not doing the research and so on. So typically, the disparity between the developed nations and the developing countries will actually become even more because of AI. So as we move towards singularity, now that is another problem. The human species, as a species, as a group, they will also get further divided on the basis of your economic conditions. The global north is likely to become even more north in terms of prosperity and whatnot. And since they are that, they are able to provide better education, better health, and whatnot. So AI going forward is likely to, in fact, enhance and increase the disparity which already exists. So that is one of the problems. The second uh, uh, problem of AI, as you can imagine, because see, when you're talking about singularity, let me roll back and talk about aspect. When you're talking of, imagine it like this, 21. By that time, singularity will be there. Devices, so maybe a chip in the interface. So that BCI research shows that we already have situations, and you might have seen that with parity, but it will also enhance a lot of heat. It will also have a huge energy signature. We don't know yet. But all this carbon emission called permafrost. You might already be knowing about that. Permafrost is like several tens of feet of snow which has never melted ever. We have known that. So permafrost is permanent in the frost condition, and permafrost has really prevented our species, humans, by capturing. Heating has started. The the heat starts to give what you call uh, starts melting the ice a little bit. And when the ice gets melted, guess what happens? On the polar cap, what is the color of that? White, right? And white color absorbs less energy, less sunlight. And when the ice melts, the surface below is not white, it is black, or it is like, dark brown or something like that. And guess what? Now the surface is brown, so it will absorb more heat, it will reflect less heat because it is no longer white, and that will further melt more ice. And so this is kind of called a self-feedback loop. And if the self-feedback loop starts, it is very hard to control, as you can imagine. So um, I guess we are kind of running close to the 30 minutes that I had set for discussing this. And there are a lot of things that we can discuss more about all these. But I think I will stop here, and with the concluding remark that AI, first of all, that advancement and singularity is inevitable. I mean, it will happen now. We have got so much of advancements. Um, there are some important decisions need to be made, and more importantly, we have to kind of look at the advantages and the disadvantages, the perils of AI, and that is an important question. It may even be an existential question for humans and for our species. So let me stop sharing the slides, and if there are any questions, uh, let us discuss that. Do you want the? Can I take the slides off?
Yes, sir. You can.
Okay. All right. So, are there any questions?
Sir, is there any possibility to change the that you say about the climate change through AI? So,
That is a great question. But then again, as I was talking about at the end of my discussion, um, the self-feedback loop. So if you're trying to use AI for finding a solution, that is one part. But running the AI will require more energy and it will generate heat. So it will, in finding the solutions, you will make the problem worse, if that makes sense.
so it
So
includes
you might find a solution.
the hardware that like IoT in there.
No, yes. IoT is of course is ubiquitous. I mean that is the one of the building blocks of AI.
Okay,
But the
sir.
important part is when you are running, when you're trying to find a solution using AI. But maybe there is a way to handle that, and we don't know it yet. See, when the singularity is reached, AI will definitely work on algorithms, and the understanding through enhanced, augmented understanding for humans, it will be of a different dimension. Imagine when you are able to see more than what meets the eye, then your perception and your understanding of the phenomenon is at a different level we can't imagine right now. So maybe you're right, and I would like to actually uh, definitely hope that AI will have the solutions that we need to preserve and continue the species. So definitely that is definitely possible. But how will it be? That we cannot really solve that problem. Einstein said that you cannot solve a problem at the level at which it was created. So you have to go one level up to be able to solve it.
Uh,
And that level up will be singularity.
sure, sir. Thank you, sir.
Sure. All right. Well, thank you so much.
Yes,
And
sir. Just a wait, sir.
yes.
Thank you, sir, for making us pause and ponder. Are we ready for this technological future? Thank you once again.
All right. Thank you. Thank you. It was great talking with you, and look
Oh,
forward to maybe hearing from you sometime.
Okay, sir. Thank you, sir.
Thank you.
Okay, sir.
Bye-bye.
Bye, sir. Bye. Uh,
Now it's time to welcome our next guest, Dr. Nalik Ulapne sir, who is a research fellow at School of Computing, Engineering and Mathematical Sciences, La Trobe University, Melbourne, Australia. Dr. Ulapne is a researcher who integrates mathematical modeling, engineering, systems design, data analytics, and design science research principles to address challenges in complex systems, including healthcare. He has held various research and teaching positions at several institutions, including the University of Technology, Sydney, the University of Melbourne, La Trobe University, Swinburne University of Technology, and the Olivia Newton-John Cancer Wellness and Research Center. Additionally, Dr. Lapne serves in several editorial roles for books and academic journals that focuses on the application of artificial intelligence in healthcare. I request Sir to kindly share a few insights with the audience on the topic Transforming Connectivity for a Smarter Future. IoT meets AI.
yes, sir. You can share the screen, sir.
Thank you very much for that introduction. So yes, I'm Nalik Ulepane, and I hope everybody can hear and see me.
Yes, sir. It's definitely.
So yeah, very happy to speak to you all today. So yep, I'll share a few slides with you. Hope you can see some PowerPoint slides.
Yes, sir. We see. No problem, sir. You can continue, sir.
Yeah, thank you for that. Yeah. So yes, so I just joined in halfway through the last talk. It was very interesting to hear those thoughts. And so yeah, my talk is going to be along similar lines. So it's going to be about the AI transformation the world is facing right now, and what might the future hold when we combine IoT with AI. So that's going to be the gist of my talk today. So let's get started. So a bit about my background before we go into the talk. So I started as an electrical and electronics engineering graduate, graduating from the University of Peradeniya down in Sri Lanka. Then I came to Australia for my PhD, which I did in sensors and robotics. And then I came to Melbourne University, in which I did a bit of control engineering and mathematical modeling. And now I work at La Trobe University, working more closely with the healthcare, introduction of artificial intelligence and digital technologies into healthcare. So that's a bit about my background and my career trajectory I have taken. And if we go into the talk today, so let's start with a bit of history. So it's important to put things into perspective to understand where this technological transition started and how it has evolved and where we have come to now. So the modern technology and modern industry actually started late in the 18th century. You might have heard and read about the steam engine and all that. So before that, we've had a bit of like firewood, charcoal, the fossil fuels in terms of charcoal was still used. In terms of engine, that came mainly from Europe, you got the steam engine. And then came the electricity transition. You got electricity transmission and the invention of the light bulb and all that happened. So that's basically industry 2.0. So we consider the steam engine era as industry 1.0. And you have electricity in industry 2.0, the generation of the industry. And late in the 20th century, that means like after about like 1950s, we have the invention of the transistor, and then that paved way for a huge boom in electronics. So now we have like microchips, microprocessors, and microcomputers. So the start for that actually started in the 1940s and 1950s. And that electronics, the advancements of electronics actually made a big difference to making things possible to come where we are right now. And now we are in the Industry 4.0 era, where we actually have cyber physical systems and Internet of Things. And we are in an era where trying to integrate AI with other technologies. So that's a bit of a history on the industry kind of like evolution or transition. So that's not the end of the story. We have so many other technologies as well. So when you talk about IoT, another technological transition or evolution we need to consider is the evolution of communication. So communication, basically in the old days, we had very primitive kind of ways of technologies or techniques of communicating, which obviously worked, but weren't very efficient. So what happened again in Europe was kind of like the invention of the wire connected telephone that happened in kind of like 1876. And then later in the 19th century, radio communication happened. And then came the world wars, and actually these inventions, the telephone and the radio communication, actually made a big contribution to kind of like creating those wars. So that's kind of like a downside of technology then and there itself. So you had the world wars, and like amidst the world wars, you had the introduction of the television. So in the television, you used the same electromagnetic spectrum, but you could actually transmit video and audio. And then we came into the analog cellular phone era, where you had like big handheld mobile devices, which you could actually carry on your hand and make phone calls. So that was the first generation, or the 1G generation of wireless communication. And then we came on to the early 1990s, in which we had the 2G era, which include voice plus text messages, you call SMS. That's something you hardly, that terminology is something you hardly use nowadays, but like in the old days, it was called SMS. So SMS and voice calls were the 2G generation, and then we come into 3G generation. So then you have voice, text, and a little bit of internet in your mobile device. So that was 3G. And then in the 2010s, we had the 4G era. So 4G era involves high-speed internet, and you have like enhanced streaming experiences, so you can basically watch a movie in your mobile phone. And then we have 5G, which is in the 2020s and beyond. So here you have the same capabilities you had in 4G, but with faster internet speeds and capacities. And now you basically have like very advanced smartphones, but this is not the end of the line. So 6G is still being researched. So they're kind of expecting that to be implemented somewhere in 2030s. So basically, yeah, things are getting faster, but the radiation impacts are also getting bigger and bigger. So this is kind of like, again, kind of like a brief wrap up of the history we have passed in kind of like the evolution of communication technologies, which is also very important to know. And it's when you know this history, it's kind of like easy for you to kind of like put things into perspective and kind of like think like, okay, what have we done? What have we done right, and what has gone wrong, and what could go wrong in the future? So you can basically kind of like do some synthesizing like that. So it's very important to understand and know this history. And we also need to know a bit about artificial intelligence. So artificial intelligence, basically, it came into play. If I go back into the previous slides, so it came into play in this industry 3.0 era in the 1950s, when the transistors and the analog electronics and the conversion to digital electronics happened. So in this era, in the 1950s and 60s, that was when artificial intelligence came out as a concept. And then in 1960s, we had like basic computers. So basically we had like some very primitive first generation kind of AI tools. And guess what? In 1960s, we had a chatbot. So that was called ELISA. Some of you might have heard of it. So that was kind of like a hard code chatbot kind of like program which was trained to behave like a psychotherapist. So it wasn't as advanced as some of the chatbots or ChatGPT we have nowadays, but it was good enough to kind of like, like when a person kind of like types in their computer, then ELISA sits at the back end, and then ELISA reads that text and then do some textual analysis based on kind of like hard-coded logic, and then it does some text matching and then gives a response, and then the person sitting in front of the computer would kind of think they're actually talking to a psychotherapist or an intelligent chatbot. But it wasn't that intelligent, but that came up in 1960s. So that was one of the first developments of artificial intelligence. So moving along that trajectory, in 1970s, we had a thing called expert systems. So expert systems were again kind of like management information systems, so which were systems, software systems that were helping organizations to kind of streamline and manage their processes, but they were all based on hard-coded logic, basically Boolean logic, flowcharts, that kind of thing. So people thought in 1960s and 70s, well, people thought that that's AI. So they thought, yeah, that's AI. So you have to have like, like hard-coded logic, and then like, like if you have like tree diagrams and Venn diagrams and kind of like flowcharts and things, that will solve all their problems. But as we know nowadays, that is a very limited kind of like approach that we can take into artificial intelligence. So what happened in 1970s is like, okay, they saw some progress, but artificial intelligence wasn't actually delivering what it promised. So what happened in 1980s was the industry of artificial intelligence actually saw a suffering in funding. So basically, because people actually thought that that was all movies, or that was just a lot of hype but not delivering. So that kind of an attitude. So in the 1980s era, it was known as the AI winter, where lack of funding resulted in lack of research and nothing much really happened, except for the movies like you had like Terminator and things coming up. So that also kind of gave a bad rep to AI in Hollywood. So that also might have created some stigma and phobia in people, which kind of like made people resist AI in that era itself. So that was the 1980s, the AI winter. And then something happened in 1990. So this actually started in 1985 by, I think, Carnegie Mellon University, if I'm not mistaken. And it was a collaboration with IBM as well. So it was a chess engine. So basically, it was one of those programs which can play chess. And funnily enough, it was able to beat a chess grandmaster known as Garry Kasparov, you might know sometimes. So he was beaten in 1997. So in his first attempt in 1996, Garry Kasparov was able to beat the chess engine. The chess engine was called Deep Blue. And in 1997, there was a rematch. And in that, Garry Kasparov actually lost. So that was the first instance where people were convinced that artificial intelligence can actually beat human intelligence in certain contexts. So this again in 1990s, late 1990s, it gave a lot of interest into AI again. And then again, funding came in. So the universities started looking into mathematical modeling, algorithms, and all that. So that is where the modern AI resurgence happened in early 2000s, where we had an advancement in AI through generation of new algorithms. So these algorithms were much more advanced than the flowcharts or Venn diagrams or whatever you had in 1970s. So these involved probabilistic approaches, things like Gaussian processes, and then you have like deterministic probabilistic mixers like neural networks. And people were actually looking at artificial intelligence in a mathematical sense. So that actually paved way to the modern advancements we have. So that delivered a lot of impact. And then neural networks picked on traction because neural networks were very powerful. They were computationally expensive, but there were ways to make them run faster. There are other approaches like, say, probabilistic, say, support vector machines, Gaussian processors, and things like that, which are probabilistic, data intensive, but they are relatively slower and not quite feasible to work with large data sets. But neural networks, they are essentially black boxes, but they can work very fast if you kind of define your problem and kind of like break it down into small components. So that actually led into 2010s, where people actually thought of, like introducing new kernels and, like clustering small neural networks and making basically large neural networks. So those were called deep neural networks. So deep neural networks is what actually enabled us kind of like image recognition, video, text recognitions, and all that. So most of the modern the advancements came through deep neural networks. And then we come on to 2020s, and then you all would have seen the pinnacle, which is ChatGPT. It's basically the categorically they're called generative AI. So generative AI means like there is an AI algorithm which actually looks at a lot of examples, previous examples, and it can generate new ones which have never existed, and they look pretty good. So that's the idea of generative AI. So ChatGPT is a commonly known example. There are a number of other tools as well. So this evolution is also very interesting to know and keep track of, because that also gives you an idea of how our AI and computation capabilities have advanced. So now, where have we come to in present day? So in present day, we have the capability to kind of like augment or combine IoT with AI through wireless communication, advanced wireless communication capabilities, including 5G. And in 2030s, probably you would have 6G as well, which is pretty much 5G, but again, like much higher bandwidth and much faster internet and so on, at the expense of having more radiation, of course. So basically, some of the opportunities we have is intelligent industries and utilities. I'll go into a few case studies in this about this in a few minutes. And then autonomous systems, I'm pretty sure you'd have seen these things. I mean, like these things, sometimes you do kind of like, like projects in universities as well. And if you want an industry example, just look at Tesla. So autonomous vehicles, and there are other autonomous systems you can think of. And then smart cities. Smart cities is still conceptual, but people are exploring. Again, if you want a case study about this, read about Singapore smart cities. So what I've heard about that is like they talked about it about like 10 years ago. So it's basically they used like drones and scanners, and they created a 3D model of the whole of Singapore. So Singapore is a small block of land. So they created a 3D model, and it seems they have done some artificial intelligence on it now, and they can kind of like forecast like traffic and like like expansion planning and all that. Seems to be possible. So that's one of the examples you can have for smart cities. It might be happening elsewhere as well, but mostly it's still at a research and conceptual stage. And intelligent agriculture, definitely yes. This is already implemented, especially in the West. Again, IoT with not much AI, I would say. The algorithms would be pretty primitive still. But you can do a lot about agriculture, because obviously for sustainability, food is important. We need to make more food with the growing population, and also think about sustainability as well along the line. So intelligent agriculture is a very useful sector. And especially if you look at, say, like India, Pakistan, Sri Lanka, I think I'm not very sure about the agriculture industry, kind of like industrialized agriculture in other countries. But if I speak of my experiences in Sri Lanka, they kind of still do very much traditional old-fashioned agriculture using kind of like modern fertilizers and that, and which is not very effective. You can do a lot of robotics, and you can use drones and other devices. So there's opportunity in intelligent agriculture nowadays. And also we have enhanced healthcare, which has also taken traction mostly in the West. So again, I'll speak a little bit more into this in the next few slides. And of course, like you have all these kind of like technological advancements and opportunities, but do not forget that we also have to think about sustainability. because I heard like half of the talk of the previous speaker. So sustainability is very important. So I think my personal opinion is that we have to use technology to monitor the environment so we can learn more. So basically, if we are doing something wrong, we would be able to learn more if we use more sensors and kind of like keep track of things. So, and then the other thing is like basically kind of like, like practice minimalism as much as you can. I mean, like use what you need, but like don't be greedy and don't kind of like over exhaust your resources no matter where you are on the earth. So ultimately, everything should pin down onto sustainability because that is the ultimate goal as a species for us to survive anywhere. I'll go into a few case studies. So basically, this is about smart energy. So this is from a recent review paper from IEEE Access. So the barcode is there. Feel free to scan it and read if you wish. So basically, this image is not very clear because I took the image right from the paper. So basically, I'll talk you through this. So what you see here is you see the traditional electricity network, but when it becomes smart energy, what happens is like you have your transmission lines, you have your distribution networks and all that. So basically they become kind of like sensor connected, kind of like sense their loads and their current flows, voltages and whatnot. So they use nuclear energy kind of grid. So microgrids are kind of like local and solar power, and they might be as well. And then uh, to the maximum you can to avoid wastage and eventually kind of like become more efficient. I don't ever think that moving away from human in the loop is a wise thing to do. You always need to have a human, somebody to monitor things. So you can't just give every autonomy to artificial intelligence and trust it to do the right thing because it's a machine, it's a device after all, and it's going to fail. And then you will have another component which is called the virtual grid. So which is essentially a mathematical model which helps you kind of monitor, track, and simulate different scenarios of your actual grid. So you will have your control schema, you will have your mathematical model or the virtual grid, and then essentially the other component is 5G network. So within the next few decades, you might even need more bandwidth. So you might need a 6G network here. So basically, this kind of like go hand in hand to serve a much greater need. And another example I would go into is smart healthcare. I'm not sure whether you have heard a product called BioSolutions. So some care. So in the West, especially, the hospitals are very expensive. You like that. So this kind of solution enables that. So it's designed for patients to stay at home. Thank you all for your attention, and I'm open to take any questions or comments. Retinal part, you mean the eye?
Yep.
In the inside interior of the eye. So basically, it would ideally have to be non-invasive. There are some devices which you can actually view the eye in very detail. Kind of, there are certain cameras and certain devices which you can do. And so essentially you have to be careful about two things. One is you should not damage the nerves by any lights or any lasers you might be pointing at the eye. And the other thing is like it must be convenient enough. So basically, I have seen capabilities, for example, so I wear prescription glasses. So basically, there are ways to kind of like, like do your eye test at home, and then you can kind of like generate a prescription, and then you can upload it somewhere, and you can get your glasses delivered at home. That's still not very good. I would still recommend going to a proper optician and getting them tested, but those capabilities are there. But for any eye condition, say for example glaucoma, or if you want to kind of say like like you want to find out whether a retina has been damaged by a certain health condition or something like that. So there could be possibilities, and what's more important is like to be careful about the eye. And also, like say for example, if you consider like India or even like rural communities, if it's difficult for people to actually find an optician and come to, say, a hospital or other facilities, it might be wise to kind of like scan the market for any kind of devices which they can say, for example, if they're having, say, glaucoma or something like that. Anything that they can check their eyes at home and generate a report and send it to a hospital remotely. That'll be interesting. I haven't seen any examples commercially available myself, but I might be wrong. I mean, like, there might be some. There are plenty of things I haven't seen. But I haven't seen any eye-related products like that because I think eye is particularly sensitive and it's kind of dangerous to play with the eye. So that's one constraint. I think people are very cautious about the eye.
Okay, sir.
But if you look at like other things, say like heart monitors, blood pressure, or like blood oxygen levels, so those things you have like plenty of mobile devices you can just buy off from Amazon if you wish, and then you can plug it in and check yourself. But I'm 50-50 with that. There might be some devices, there might not be. But if there is a real problem, real need for that, I think it's definitely worth investigating in the interest of delivering services to rural communities who might be having difficulties reaching a hospital or an optician.
Okay, sir. Thank you. One more question from the student, sir. Just wait, sir.
Yes.
So I would like to ask that, as you suggested that we can use AI, IoT using AI to be sustainable and in intelligent agriculture. But how can it be possible if AI is the part of the problem, like climate change and all? So using those solving problem, that can be a bit difficult because the major problem we face today is the cooling of the server farms that are required to run these AIs. So what's your
Correct.
view on that?
Correct. Very good question. That is a very good question. So basically, one of the disadvantages of AI is kind of like the energy it requires. So basically, there are several ways of solving it. So you might have heard about like say edge computing, cloud computing, fog computing, and that.
Yes, sir.
So in edge computing, what you normally do is that you kind of try to kind of deploy your servers kind of like locally. So what you do there is like you're not going to use like a very advanced server there. You're going to use kind of like a very small scale, simple server just to serve your purpose, your farm or your hospital or your home, and you would have that, and then you would kind of like have a lot of those systems. So hopefully that actually can help in reducing some of the cooling effects or the electricity consumption required. And the other problem is basically you can just use the cloud. So when you use cloud servers, basically again like you find them in different places on the earth, and they consume a lot of energy. But the good thing is like they kind of try to use kind of like renewable energies as well to kind of balance out the effect. But your question is kind of like it's a very good question because it becomes a part of the problem because more you use AI, more expensive the health and the environmental implications also will be. So basically, again, there is no straightforward answer to that problem. Again, especially you have to just monitor and keep monitoring and then kind of do the needful as the situations arise. Because it's there's no real way to address that problem without using energy, because currently AI uses energy and you have to produce energy, and we have limited sources of energy. People argue kind of like alternative ways of kind of like like deploying servers in space and all that, so then you can exploit solar energy more, and then you can probably have servers deployed in satellites and all that. So that's also another solution people talk about, which might be viable. But then again, like it's like land pollution, water pollution, air pollution, and then within a few more years or decades, we might be talking about space pollution as well, because too many people have sent too many devices onto space. So again, like technology is like that. It's a beautiful thing, but there is also trade-offs like that. So there is no straightforward answer. at least for now, on how to solve the high demand for energy with AI. And like you said, AI is a part of the problem, but that does not mean you shouldn't use AI. It means you should use AI still, but then you have to keep on monitoring, keep on learning, and keep on innovating of new ways to manage the new demands of energy.
Thank you, sir.
You're welcome.
Thank you, sir.
Thank you, sir.
Yeah.
I hope this connect between IoT and AI will help many researchers present here. The next keynote speaker for today is Dr. Praveen RVS, Director Project Engineer, LTI Mindtree, USA. We are trying to connect with sir.
Yes, sir. Nalika, sir. Now, thank you very much. Now you can, if you want to hear the Praveen, sir, you can stay or you can leave. Okay.
Thank you.
Hello, Praveen, sir.
Yeah, you can
Yeah.
hear me.
Yes, sir. I hear you. Good morning, sir.
Morning. Yeah. Can you see me?
Yes, sir. I'll see you, sir.
Okay, great.
Sir, 1 minute, sir. Just introduction, then I will let you give the handover to so that you can start.
Good morning, sir. Dr. Praveen RVS is distinguished leader in data, product engineering, and innovation, bringing over 2 decades of expertise as technology consultant and specialist in product development and conceptualization. Throughout his career, he has successfully led development team and implemented software solutions, consistently delivering high-quality product on time and within budget. As an accredited project strategist, Dr. Praveen possesses a proven track record in understanding, defining, and shaping client needs. With background in expertise architecture and comprehensive business analysis, he has hands-on experience in critical areas such as enterprise BI, data visualization, search-based data discovery, data warehousing, big data analytics, advanced analytics, machine learning, artificial intelligence, computer visioning, and journey analytics. He holds numerous certifications include PMI PMP, SAFE 4.5, CCNA, MCP, MCTS, ITI LV3, and Lean Six Sigma certifications. Sir has patented over 20 innovations in AI, machine learning, and cloud computing. Additionally, he is the author of 9 cutting-edge technology books on data engineering, IoT, AI, and machine learning. Beyond his professional achievements, Dr. Praveen contributes to academic community through his research and publications, aiming to bridge the gap between traditional knowledge and modern technological advancement. We are delighted to have your virtual presence, sir, today. Kindly grace us with your thoughts on the topic, impact and challenges in implementing AI in the enterprises.
Okay, sir. Now you can share the screen, sir.
Yeah, great. Thank you. I hope you're able to see my screen.
Not right now, sir. Yeah. Yes, sir. It is visible clearly. You
Great.
can, okay, sir.
Okay.
Yes, you can start, sir.
Sure, it's fit. Okay, great. Thank you so much for the quick introduction, and thank you so much for all the patient audience who have been really, really patient and listening to each and every keynote speaker. Okay, yeah. So the topic that I'm going to talk about, today is impact and challenges in implementing AI in enterprises. I think this is one of the most important topic for us to even understand, because enterprises are actually catching up the race on adapting to AI, right? GenAI has disrupted the whole landscape altogether in terms of giving the users the capability of thinking about use cases that they can implement in AI, right? And also making sure the last mile of AI is adapted by them. The use cases are being adapted by the people who are talking about it. And now they also can start creating their own set of understanding in terms of how they would want to utilize, understand, and reinforce AI into it. Now that gives enterprises a very big challenge in one, adapting to the changing, ever-changing consumer behavior. And apart from that, it's also very, very important for them to see how they would be much ahead to the curve that a customer would really ask for. I'm emphasizing a lot on the customer side of it because we deal with customer and their experiences when we talk about AI, because it's about use cases and ultimately making sure the last mile value is being extracted for them. Today, we will talk, of course, it's a huge topic to talk about, but I will try my best in terms of giving some perspective for you in terms of how hard it is for organizations to adapt to the strategy of enterprise AI, and what are the best practices and the impacts and challenges that they normally tackle with. I'm sure we will also be discussing about a use case that has really made a significant impact using AI. So one of the biggest challenges most of the organizations actually face is evolving the AI landscape. Every organization tries to create a very strong landscape, creating confidence, like we're preparing the AI with the data that they have, the data that they deal with on a day-to-day basis, and also getting it ready to the use cases that they're trying to solve it, right? So it's important that how do they evolve from one stage of the data and adapting the AI models into it, and then converting that to the next level, because the maturity of the data and the maturity of the respective users is coming into picture. That needs to be tackled in. And that's exactly what we'll get to see in this place. Now, what we see is the challenges is there are quality issues. I mean, according to a research, like 37% of the organizations report wasted resources due to inconsistency and incomplete data. Infrastructure limitations, it's adaptively seen across, right? Organizations really struggle in creating a very strong infrastructure, and the legacy systems struggle with AI for sure. We all know that. Workloads requiring cloud adaptation, scalability in terms of architecture, skill set of individuals is also a big challenge in terms of catching up on ever-changing landscapes. Algorithm optimacy is another part. You have a black box in typical AI models that have been run through from ages together. You really can't go into this AI models and start making pivotal changes. So it's very, very critical that the decision-making part is something which has to be seen in, but it's not seen through. These are some of those challenges that ideally come across as technical hurdles for us. But apart from that, you also see biggest barriers that organizations carry. That's because most of the organizations are not ready adapting to the skill demand. You see 31% of the enterprises lack staff to bridge AI and business needs. Then you have cultural resistance. A lot of organizations see a lot of people being in the comfort zone, right? What they say is, I think 45% of the employees fear job displacement despite AI's augmentation role, right? And there is a serious emphasis in terms of changing, adapting into it, learning and relearning part, and lots of stuff is happening around. But you also see siloed operations. This is a very, very critical factor. Cross-functional collaboration, and with respect to the IT, data science, and business units, is not well seen across because they have independent functions and processes to work with, and of course they obviously work in siloed manner. But the collaboration is very, very critical for us to understand change, right? So this change is something which is obviously seen as a very strong impact across organizations for adapting to AI changes. How do we solve this? right? Operational transformations, right? Process automation, ideally you get to see 20 to 30% of reduction in IT support through AI-driven ticket solution. Predictive maintenance part of it, you see 40% of fewer equipment failures in manufacturing via IoT plus AI integration. Innovation drivers, like basically hyper-personalization, AI-enabled mass customization, product development. Decision acceleration, that is real-time analytics, reduction in strategic planning cycles by 60%. So there's a lot that you gain out of adaptability of AI for sure. But how do you get to this impact? What is it that you need to do in order to get to this impact? The frameworks, that's what matters, right? Traditional approaches that we've seen is like the data strategy, retrospective reporting, talent models. These are something which we've seen across, but in order to go to the AI optimized approach, real-time, like for example, the real-time streaming analytics, cross-functional AI center for excellence, hybrid cloud edge architectures, right? You need to have a strong strategy, AI strategy, which is basically the enterprise AI platform. And that's exactly what we talk about. Framework for enterprise AI adoption. What you do is the AI technology use cases, that is predictability, classification, language, vision, AI technology with respect to analytics, data science, and deep learning part of it are the core AI technologies that you get into. Where in this space, you convert them into product and solution areas. How do you do that? You create virtual assistants, you create conversational assistants, you create automation assistants, and build a process-driven approach for it. Once you have a process-driven approach, you convert that into an enterprise functionality. That is, streamline that to the respective departments like the customer service department, the human resource department, the sales and management, marketing team departments. They adapt to it. They use it. They give the feedback in terms of how the process has to be streamlined. They give the data, they give the user experiences, which can be converted into a real-time use cases in the production side. Once this is adapted by the organization, they can start visualizing this adaptation to convert that as an option for the end customers as well. And that's exactly what you see, strategic differentiation. You see the highlight is about strategic differentiation. Once you adapt into it, you know that you are actually ready. One, by understanding the conversational change, and also understand the behavioral aspects that the customer would come across in adapting your AI. What you see is ultimate customer satisfaction, cost reduction, because it's obvious, we get to see the faster resolution, quicker resolution time for any activity, lesser steps in terms of doing an action, lesser people involved in, obviously you see cost reduction in coming in, and asset optimization part. New revenue generation options, because you have better adaptability options, you have better ways of doing things, obviously you see new revenue streams coming in place, with new type of customers coming into the picture, so life cycles can get better and better. And on top of it, you also have competitive advantage, because people who don't adapt into it, they are not ready for this adaptation of AI. You will have a competitive advantage. The first mover's advantage is always available for you. And accurate and faster decision making, more the precise level of data that you have, the adaptation of data that you have, the AI models give you better results in terms of its accuracy, the better the decision making capability that you have, and the faster decision making capability that you have, because predictability comes into picture right now. And then, of course, the risk management and the governance factor that you get to see it. That's the objectives of the business part of it. Now, when we get into this kind of an adaptation, you get to see that how it functionally lays out. You have business users, you have AI stores, you have a defined layer of APIs, you have engineering life cycles, and then that's the place where you have the biggest major part, that is the infrastructure. Remember, in the first slide, we discussed about the challenges of having infrastructure and the readiness of infrastructure, because there's a lot of legacy-based infrastructure that is still being adapted, and it struggles to scale, it struggles to evolve, right? So that's the place where we have a framework which talks about how it has been emphasized and important that we adapt into the new forms of infrastructure and management part of cloud, right? And then we get into a use case part of it. What we've done is, in my experience talking to customers, I was talking to a couple of customers back in the manufacturing segment who were very, very keen in adapting AI, and that's exactly the case study format that I have right at the bottom. But you know what? The market scalability of this entire AI adaptability is close to 1.8 trillion, projected to be by 2030. And you have an implementation success rate which is less than 35%. And imagine about if you manage to increase this percentage level much greater than 35%, like around 50% of it, I think the market cap is going to be far more bigger, more number of people getting wrapped into it, more number of jobs being created. And of course, yeah, we have a much more better productivity, scalability, and other factors. Ideally, the challenges and analysis that you get to see is data governance and maturity models. Guys, we all know for a fact that AI needs data. No organization is ready for adaptability of AI or readiness for AI story unless until they have data ready. Data doesn't get ready in just 1 month or 1 quarter or 1 year. It takes a good evolution time. It takes a good cycles of data to be ready for AI adaptation. So organizations who have started working on AI, it's not easy for them to actually sustain that AI journey unless until you have the data readiness with you. And this data readiness is all about the process and the procedure, the governance, the security layers that you've created, where there are defined personas who would access what data they would access, how they would access, how it is being created, how it is retained, how it is being regenerated. If these definitions are not being put across, then it's impossible for an organization to sustain the AI story. And hence, we see that the change management checklist talks about stakeholder alignment, phase rollout plan, continuous learning programs. And that's one of the best possible methods you would go and start implementing an enterprise AI story in an organization. I have a case study that talks about just few lines about it. Just think about it. We have 40% of production downtime from a legacy system. We all know that manufacturing organizations have legacy systems, and it's very difficult for them to actually replace it. It's not easy for them to replace it because it has so many binding factors in it to this process lines. And that's exactly what the digital twin AI actually adapted in the data, the scraper of this data. It has converted that into a data model. They could manage to use the data model to convert that into an analytic-based information, which is converted in the form of a nudge. And this nudge has given them a signal to tell that, hey, this system is not functioning right. And with the digital twin, they could see exactly the place where this alert has come from, and they could manage to put a resource to resolve that particular issue then and there itself. This reduced the time, this reduced the RCA, the root cause analysis process. It reduced the resource, ambiguity in the resource, like who's going to solve, when it's going to be solved, how it's going to be solved, because there's a defined SLA, and we exactly know which location it is from, because there's a sense of ownership in the manufacturing plant. And due to this, they started seeing savings in their entire workflow, and on an average, we could calculate that it is $2.8 million, right, as savings, right? So AI really works. AI adaptability to AI really works. Enterprise level AI implementation really makes an impact for traditional organizations. Imagine about high tech, the consumer tech. You have finance, you have banking. Almost all of these industries can see a massive change. I've taken manufacturing because legacy systems are literally being seen in manufacturing industry a lot, right? And that's one of the reasons I put across. I have some comparisons, right? Whenever we talk about business and AI, it's about the balance that we get to see on the consumer and the business expectations side. It's very critical that you don't want to adapt into technology just because it's available. You need to have an expectation and a demand for that technology. If you don't need AI, you just should not use AI for the fancy of it, because it comes with a cost, right? So if you see here, the engagement factor on a business side, the 360 view, the efficiency, the relevance, the automation, and the growth factor are pivotal considerations for any business management team or any engineering team to decide whether they wanted to get into an AI implementation. Now, on the same side, the contrary of it, the customers, the contactless capability, real-time, frictionless, personalization, contextual part of it, and trusted and proactive measures. If there is an expectation on these lines from the customer, and if there is an expectation on the business side, that's when you would want to start creating a format, right, in which you would want to use AI to solve those very, very important use cases which are supposed to be, making a huge impressional change by the customer, right? And you get to see more about it, what, again, as I said, activating enterprise data, it gives you a very strong, intelligent insight in terms of which are the areas you would want to implement AI, which are the areas you see that AI can make a difference, and start impacting the customer behavior part of it, right? I'm a huge advocate in terms of adapting data and the data story, and use AI as a byproduct, right? It could be AI, it could be ML, it could be Gen AI for that matter. But data story is pivotal for any such kind of an adaptation, right? And ultimately, yeah, I've also created one business demand to compete with customer-focused transformations. It's critical that you get to see the customer-focused transformations happening around, and it is important that we measure these kind of transformations around. Excuse me. And one of the biggest factors that you get to see is the security and the governance layers, which is important. Whenever we get to the customer layer, if you see here, in my image, right at the business layers, it's important that you get to see the governance is actually an important factor. It should be an independent layer altogether. Inside the governance, you have the security, and you also have an identification factor, so that you know that you are very confident about adapting to AI and giving the trust factor to our customers, so that they are easy to adapt into it, right? Whether it's corporations, it's individuals, doesn't matter. It's about simplicity, reliability, value, speed, and trust. Underline the word called trust, guys. It's important because you don't want to blindly think about AI, right? Excuse me, right? I think these are certain important factors that I would wanted to call you up today in a short period of time that I got in. I'm open to questions.
Sir, can you suggest what AI proficiency will help my students to grow in this area?
Yeah, sure. Critical question for most of the people who would plan to get into AI. See, AI proficiency, I would say, try to understand how the data can help any AI journey to start off with, right? What is important is how the data sourcing, how the data modeling, and how the AI modeling is been connected. Like, if you see there are three major components in it. One is the data sourcing factor. If you understand what type of data, the schemas of data, the variants of data that is coming in through, and then how this data is connecting to your AI models, right? Today you have ChatGPT available, you can connect a SQL DB data and experiment with that and start querying how, on the data itself, how simple NLP queries can be gotten, and then you can understand how the landscape is being gotten, is breaking up rather, right? So it's important that people understand the journey of data and see what are the components of various AI models that are available in the market, like an open source models, can be bought in there to create small use cases, create very, very small capsule kind of use cases, like understanding sales, journey, understanding the lifetime value of a customer, understanding the purchase value of a customer, right? These are simple examples, very, very simple examples, right? If you can pick up the open source models and the Gen AI models that are available right now and connect it to a data and start curating these questions to that particular data, I think that's a skill set that will take you a long way.
Thank you, sir.
Hello, sir.
Yeah.
I have one question. Like, you solve problems for AI enterprise. I would love to tell you that myself, Tanmay Chaturvedi, I'm running a small student startup. So we are a team of data engineers, data scientists, and financial consultants. We are trying to solve asset management problem for middle class individuals. So one problem that we are facing is when it comes to machine learning module optimization. Our complete chain is agentic AI chain, and in which we are dealing multiple machine learning models tuned on different DMAT accounts of different customers. The problem is it takes a lot of time for tuning those modules on the data set of customers. So we are a very small startup and we cannot afford big GPUs, right? We are barely getting incubation funds. So that's a problem. How to solve this problem for people like us who are not having that sort of resources?
Yeah, technically there is very little that has been that I can talk about is like, the quantum options that are available, right? There are so many startups which have come into who are hiring quantum systems for you. And you can use blockchain in order to create the entry gates for the qubits that you normally wanted to use across and convert your core, solving points into qubits, right? So for example, whenever you have a logical functioning which is going into the DMAT part, right? Convert that into qubits. Store that particular functionality via each and every login account via blockchain to the qubits. I think that will solve your problem of quantifying it to the larger scale and extract that qubits into a conversion rate and put it into a normal CPU. This could be an application. This can just be an application, right? So if you see, the landscape is very simple, that you have a pipeline that is connecting to as a converting line from blockchain to qubits. From the qubits, you have a response coming back, right? And you have a converter which will convert that into a simple application language, right? If you can crack this out, I think you can just hire a high-level quantum application. You would need a security layer of a quantification which will be solved by blockchain itself. You don't have to get into that part also. Over a period of time, when you scale into the quantum systems out there, the qubits arrangement has to be bottom. That's the place where you normally do a quantum evolving, right? And quantum evolving is just a line of frameworks that you normally write in, and it's a layers that you normally put in. This will scale your job. You can avoid getting into multiple GPUs and establishment of a larger infrastructure, right? But yeah, this needs a little bit of expertise. I think you just have to bubble around on the blockchain and quantum part of it. If you can crack this out, there are a lot of options available. You can crack this out. You can easily scale this up. But go for a smaller, cheaper quantum systems, not a high ones.
And for tuning the module, should we go with GPUs or we should directly use cloud for it?
No. I think adapt into a cloud. Tuning models is go into a cloud. Maybe an AWS or Azure would give you a much more organized model. And also use Hugging Face as one of those options where you would normally wanted to go bring in an adapted model instead of just taking a vanilla version. Don't take the vanilla versions. Vanilla versions really don't give you the responses that you're looking for. Vanilla version is just about bringing in your data and making sure that you are doing all the whole work and then make it publicly available. I would say use the models which are already being used, prepared by a use case feed it with data. It should have gone through 1 or 2 life cycles. Only then you will be able to adapt into those models.
Perfect, sir. Thank you.
Yeah, great.
Thank you, sir.
Yeah. Thank you, everyone. Have a wonderful day.
Sir,
Thank you.
thank you, sir. Good afternoon, sir.
Yes, sir, I can hear you.
Okay, sir. Good afternoon.
Good afternoon.
Last, we have the keynote speaker for today is Dr. Umar Mohammed Mudebbo, Senior Researcher, Mudebbo Adama University, Yola, Nigeria. Sir is a fellow and president in Operations Research Institute for Decision Sciences and Analytics in Nigerian and executive member of African Federation of Operation Research Societies, International Federation of Operation Research Societies, and Operation Research Society of India. Dr. Umar Mohammed has published more than 50 research articles in journals of national and international repute with over 1,000 Google Scholar citations, and attended many conferences and workshops in his domain area, serving as a guest speaker and session chair. Dr. Mudebo is a recipient of university grant to study MTech in Operations Research in 2014. Then, he received the prestigious Nigerian Territory Education Trust Fund to study PhD in 2018. He is recipient of Young Researcher Award and Research Excellence Award from Institute of Scholars India in year 2020. His research area include mathematical programming and its applications, reliability optimization, fuzzy programming, multi-objective optimization, inventory and supply chain management, and sustainable development goals. We are pleased to have you with us at this online platform, sir. Kindly grace us with your thoughts on the topic, optimal resource scheduling in cloud computing environment.
Okay, sir. Now you can share the screen, sir.
Good morning.
Morning, sir. Yes, sir. Your screen is visible. You can start now, sir.
Okay, thank you very much for having me this moment.
Thank you, sir.
Even though I'm having some cold, I will manage to go through the session. As rightly pointed out, we'll be discussing on optimal resource scheduling in cloud computing environment. By myself, Dr. Omar Mohamed Modibo from Department of Operation Research, Faculty of Computing, Modibo Adama University, Yola, Nigeria. I'm very happy to be invited in this very great occasion, IEEE International Conference on Computational Communication and Information Technology, organized by IPS Academy Indoor Institute of Engineering and Science, Computer Science Department. Cloud computing is a very serious issue that we have to abstract as follows. To have an efficient resource scheduling is crucial for optimizing performances. If you have to get an optimal performance of different systems efficiently, and then you have to schedule them accordingly. That will help you reduce the cost and also ensure scalability in cloud computing environments. As cloud infrastructure continues to grow, managing computational resources effectively becomes a key challenge. So we want to believe that this aspect talks will explore just to enhance the resource allocation and utilization. Overall, you have an optimal performance of the entire system. Now, this leads us to leveraging the intelligent scheduling machine, where an organization can achieve improved efficiency, reduce latency, and better overall system performance. Basically, as an introduction, we all know cloud computing has excelled in demonstrating its significance in the development of science and technology in the current world. So, utilizing cloud technology, customers can access to have reduced resources based on a pay-per-use demand. As customers demand and they pay for the certain demand they have. So you have multiple demands online that have to be assessed, has to be shared and redistributed due to the overload and overlapping systems. So users can then examine the resources to which they have been granted access. The different scheduling methods and virtual machines it can be challenging for service providers to change their resource supply to correspond with demand because there is a high demand and you have probably the resource scheduling supply network, it will be very challenging for you to have, supply all this and then satisfy the customer demands. Resource management is very crucial for suppliers of cloud services. Now, look at the capacity of the workflow is completed through the coordination of these resource allocations. Due to the dynamism of the nature of the resources, the allocation has to be re-strategized. So we need strategic planning, depending on the terms of the service level agreements. The ISP, that is Internet Service Provider, with its unmatched scalability, flexibility, and cost effectiveness for both businesses and individuals, has emerged as paradigm shift in the field of information technology. So in this era of pervasive digitalization, cloud computing services have become crucial to a broad range of applications, from data processing, pre-processing, data storage, to machine learning, Internet of Things, installation, and many more. So while the dynamic and elastic nature of cloud system has many benefits, it also presents substantial scheduling and resource management issues. And a critical issue that necessitates creative solution is the widespread saturation of cloud resources in particular, and the difficulty of allocating customer resources such as CPU, memory, and storage to a variety of activities on workload is known as resource scheduling in the context of cloud computing. Now, resource allocation is conventional static system, might be controlled by static setups and well-defined policies. Now, the atmosphere in the cloud is everything but constant. Variable workloads, different user needs, and erratic resource contention are its defining characteristics. Even though TGS is well known and efficient, the constant scheduling world of cloud computing necessitates novel methods for resource scheduling, heterogeneous resources, virtualization techniques, and the requirement for dynamic responses to shifting workloads are all characteristics of contemporary cloud settings. And to address these challenges, new scheduling algorithms that include real-time monitoring, heuristic, and optimization approach must be created. And to that end, we provide optimal DGS, a new enhanced dynamic Johnson sequencing algorithm designed for effective resource scheduling in distributed overloading scenarios in cloud computing settings. If you have some overloading scenarios that you need to distribute them over the cloud, then you need to strategize using the optimal dynamic Johnson sequencing algorithm. You have to sequence the jobs, now allocate the jobs according to the demand, and then you look at the speed, you look at also the customer satisfaction at the same time. So this is multi-objective in nature. To satisfy these requirements of modern cloud infrastructure, the OptiDJS expand on the well-established DJS algorithm based on functionality. And these are some of the features of the optimized dynamic Johnson scheduling algorithms. Now, advanced optimization techniques incorporate state-of-the-art optimization techniques to intelligently allocate resources. It will, unlike the traditional way, it will intelligently allocate resources, ensuring an optimal max span and improve resource utilization. And the heuristic part of it is help to adapt the dynamic workloads, that is leveraging the historic method for on-the-fly decision making, optimizing resource allocation based on real-time demand. Because all what you are doing, trying to make decision optimally and satisfy the customer's demand based on the availability of the limited resources. Now, adaptive scheduling in the face of varying workloads, the new method will dynamically reconfigure resource allocation strategies, maintaining high efficiency and adaptability. Now, also, it takes care of the real-time monitoring. It continues monitor resource usage and workload patterns. What are the patterns of workload? Which systems have more workload than others? Enabling timely adjustments to resource allocation and task sequencing. The max span minimization is a very critical one. The primary objective of OptimDJS is the minimization of the max span, thereby optimizing resource usage and ensuring timely task completion. It will avoid the delay of tasks. It will balance the tasks according to the load balancing principle, prioritizing load balancing to distribute tasks evenly across available resources. It will try to avoid situation whereby other resources have more work than others. So preventing resource contention and improving system stability. Also, another feature for this very optimal model is the fault tolerance. In the event of resource failures or distributions, if there's any disruptions, then it employs fault tolerance strategy to ensure uninterrupted task execution and maintain service reliability. So this is a very critical feature of these models. This figure is a simple system design for the dynamic Johnson sequencing algorithm using MMCQ queuing system. In such a way, you see this is the scheduler system where input task processing time, and here discover time quantum, that is the TQ. What type of time required for this particular task to be stayed in a queue. Now, these tasks are placed in two servers using DJS technique. You can see you have server one here, you have the second server here. Now, it is following this MMC, that is the arrival rate, the service rate, as well as the customer behavior. Now, these are our cloud. The system will enter into this cloud. We have the external firewall. Now, this is the router. From the router, go to the server switch to the database. Also, the internal firewall will take it to the switch, the internal switch, or it will take it back to discovery server, and this will go to the workstation. Could be PCs for proper distribution. You can have PC1, PC2, different resources for different taxes. So this is the typical system design. Now, the algorithm is given in this format. You can see here you input the process time of the task. Now it will find the minimum of different time, then it will check the value of that value before. If j equals to 1, then it will take it to machine 1, that is it's trying to assign the job. Job should be placed at the first available sequence. Now, if j is equal to 2, job will be placed at the last available sequence. Now it's trying to schedule the sequencing of the job. Now it will take it to this again, remove the row, and now it will test it again. If all jobs are scheduled, then it will proceed. Otherwise, it will go back to find the minimum, the job with the minimum time of completion, and this will get to the sequence. If yes, then get the sequence of the job. Then it will follow this format, MMCQ quantum system. This is a queuing task. Then the task will be processed, and then customer departure, and then the end of the program. So this code can be written in different language. This is a flowchart of the Johnson sequencing algorithm. However, when we modify using our optimal the dynamic Johnson sequencing algorithm, this is what we have in the flowchart, showing the optimal algorithm for optimization of multiple tasks. because you're dealing with multitasking. You can see the previous one is slightly different with this one. Here, you start inputting the processing time of the matrix. Now check the value of different tags. And I less than n, it will do these tags. Now it will test if I in percentage is equal to true, then it will take the first average, second average, and then it will add up the time. So it will continue processing this total quality time until it exhausts this. Then if otherwise, it will follow if I less than n, then it will follow this. It is multitasking in nature. You can see it will check the value again for the different tasks for machine 1, machine 2. It will assign all the tasks until it get optimal taxing. So in this way, it follow MMC queuing system model. And it will process the task and then satisfy the customer and end the program. So this is a typical optimal dynamic junction sequencing algorithm which we developed and then using machine learning and what have you. So there are so many models, mathematical models, which I intentionally did not bring it here just to show us that to minimize our time. In conclusion, the model we develop represent a substantial development in the field of resource scheduling in cloud computing setting, particularly when dealing with distributed overloading scenarios. So the goal of the dynamic Johnson algorithm, successor algorithm, is to maximize scheduling effectiveness and resource utilization. That is the overall goal. If you can maximize the scheduling effectiveness and then the resource utilization, so you are done. So it builds on the algorithm fundamental concepts, and it guarantees that cloud-based system can effectively handle rising resource demands by just optimal. Thank you, sir.
Just a minute, sir.
Thank you, sir. It was very kind of you to spare the time for making this informative session a dream come true. Sir has very well explained the topic and also paved way for research gaps that can be addressed by new researchers.
Thank you, sir. Thank you to hear you and your research about your research topics. Thank you very much, sir, to give the time.
Thank you, sir. And this paper you publish the details of the paper in electronics journal in MDPI, so people can go there and get the details about this new research area. Thank you.
Okay, sir. Thank you, sir.
We are at the end of today's keynote speeches. Now, I request all the participants of the conference to disperse for lunch towards IPS mess. It is requested for all the participants to meet again after the lunch at 1:45 p.m. for sessions whose information is made available to you on the big screen. Kindly note your venues. Thank you all.